All right. Good day, everybody. Today we're gonna look at the rest of the question, as I promised in the previous video, that we're gonna look at the rest of the question on a separate video, so that we can do the higher order questions. I wanted to separate the video for question 1 because I noticed that this one, it's a higher order questions starting from 1.2 to 1.4. So I wanted to make sure that everyone will get this one since it's a higher order questions. Let's get into it. All right. Yeah, we're still doing question 1, and don't worry that much. We gonna cover question 1, and after question 1 we're gonna look at the other questions, maybe question 2, 3, Euclidean geometry, and still for science and the maths, I'm available on this channel for maths and science, physical science. So I will start with this one so that you prepare well for the trial that you'll write, and I wish you all the best for the trial. Yeah, let's get into it. So now 1.2, it's reads as follows. It says, given that a plus 64 over a is equals to 16, so 1.2.1, solve for a. Here they ask us to solve for a. So looking at this question, it says a plus 64 plus 64 over a is equals to 16. I hope you all see that. So it says we should solve for a. Okay, now when we solve for a here, we can see that there's two terms that are on the same side. These two terms, they have a common variable. That variable is a. So let's firstly start to get rid of this variable that is on the denominator, and to do that we have to multiply everything by this term, by this variable. Okay, so writing the equation as it is, a plus 64 over a is equals to 16, and then we put a bracket here to multiply this term with the variable. Our aim is to remove the variable that is on the denominator, so that we have the simplest equation, and multiply with a even on this side. Then a times a here gives us a squared, plus then this one will definitely cancel that one, and we are left with 64. Then 16 times a on this side. Let's transpose this one to the other side. We get a squared plus 64 minus 16a is equals to 0. And this one, I think it looks familiar to the ones that we were doing in the previous video, the one with x. So now let's rearrange this thing. A squared minus 16a plus 64 is equals to 0. So now we're gonna factorize this thing in such a way that the factors that we got, when they multiply, they give us positive 64, but when we add them, they give us negative 16. So those factors are, if you may think, when you add 8 plus 8, it gives you 16. So when you add negative 8 minus 8, it gives you negative 16. So, but when you multiply negative 8 and negative 8, when you multiply them together, they give you positive 64. So definitely those are the perfect factors that we have to take. And here we put a and we put a. Here is negative 8, then it's negative 8. So a minus 8 here is equals to 0. And this thing is the same as that one. So you can just take one of them and say a minus 8 is equals to 0. Then you say transpose that 8. It becomes a is equals to 8. That's it. That's it for this one. For this for 1.1.2, and let's quickly jump to 1.2.2. Okay, let's say here it's 1.2.1, 1.2.2. Okay, so now for 1.2.2, it says here hence. I want to clarify this thing. When the question says hence or otherwise, it means that for the question, that is the question that you met before, and the question that is on the above the question that you are currently in now, when it says hence or otherwise, it means that whatever you did here, you have to apply here. So I want you to have that mindset, to say that since it says hence or otherwise, sometimes they will say hence, or maybe they say hence or otherwise, as in this case. So now they said hence, so it means that whatever we did here, we have to apply even in this question. So let's see if how we're gonna apply what we did on the previous question. So in this question, hence solve for x. Here they ask us to solve for x now. 2 to the power x plus 2 to the power 6 minus x is equals to 16. Okay, so now it says that 2 to the power x plus 2 to the power 6 minus x is equals to 16. Okay, for now, let's split this term into 2 in such a way that okay, let's say 2 to the power x plus 2 to the power 6 times 2 to the power negative x. We just split this term to the power 6 minus x into 2 to the power 6 times 2 to the power negative x, then it's equal to 16. So now you can see that this one has a negative exponent. So let's move that one, that exponent, to the denominator. So 2 to the power x plus 2 to the power 6 times 1 over 2 to the power x is equals to 16. So when you multiply this value here to the power 6 times 1, it gives us 2 to the power 6. So let's multiply them together and see 2 to the power 6 over 2 to the power x is equals to 16. Okay, now we can see that here is 2 to the power 6, and here is 2 to the power x, and here is 2 to the power x, here is 16. And if you can recognize that in the previous question, we have met something like this, whereby on the previous question, this one, it says a plus 64 over a is equals to 16. And even if you can take note here, it says here 2 to the power x plus 2 to the power 6, all over 2 to the power x is equals to 16. So now you can see that this one corresponds to a and this one corresponds to 64, because 2 to the power 6 is 64. Then this one also corresponds to a and this one corresponds to 16, as it is in the previous question. That is why they said we hence or otherwise solve for x for this question. So now let's apply what we did on the previous question. So this one, we can say that, first let's write 2 to the power x plus 64 over 2 to the power x is equals to 16, so that you can see what I just explained here, that this one is 64 and this one, you can recognize that this one occupies the place whereby there was a in the previous question, and this one also. So this one is 16, and if you can see now, whatever we do, we will get, since for the previous question we got a is equals to 8, so now we can just say 2 to the power x is equals to 8, because it looks the same as the previous question. So 2 to the power x is equals to 8, and or maybe you can just introduce k here, and then you do the k method. But whatever you do, it will give you a 2 to the power x is equals to 8. So let's continue from here and say 8. We can also write 8 as 2 to the power 3. So 2 to the power x here is equals to 2 to the power 3, and 2 to the power 3 is also equals to 8. And x here, since these are the same bases, so the exponents are equal. So x is equals to 3. I hope this makes sense to you. And let's quickly look at the next question, 1.3. And now for 1.3, let's look at 1.3. It says, without using a calculator, they wrote that one in bold. Without using a calculator, calculate the value of